Okay, so I want to talk about the tools that we're going to start using tomorrow in the data recovery process. Then I'm going to cross over into some commands that we're going to need to use and understand in the data recovery process. So, first thing is, in the physical process of dealing with a hard drive to disassemble it, this is a list of the items I'm going to go through here in a few minutes that we have to do the physical recovery to reassemble, pull head assemblies out, pull platters out, and there is a bench in front of you. There is a couple of tools in front of you for removing platters, and I've got some tools that have been kind of beat up. I'm going to use yours for a second here. So I keep ordering these. This is a screwdriver to pull off the voice coil magnet. And mine have taken some abuse over the years. Really, it's just heat shrink that's supposed to be around it. And so I keep taping them up because I'm here, but I intend to put some heat shrink back on these things so that they work correctly, because the tape isn't holding up as well either. I keep ordering brand new ones from China because that's the only place you can get them. And they never come. I order them, I pay for them, and 3 weeks later, a month later, they never come. They give me a refund. They say they're in track. There actually is a tracking number, and there is things. I've done this maybe 3 or 4 times. Ordered full sets of these, and every time I do it before the next class, they never get here. So, same thing with some other things from China at this point. Things are getting held up. I never used to have any problem at all. But they get to our country, and then they get held up in customs, and we never see them again. They never get a response. Never hear from them. The whole point of this thing is to pull off the voice coil magnet of a hard drive, and I'm going to give you an example of this one. So this magnet right here, there's a magnet on top and there's a magnet on the bottom. And so we need to be able to remove this voice coil magnet so that we can pull off the entire assembly. We cannot do it if it is in the way. So now by the time I got to this spot, I would have already removed the electronics, had that removed, and I would mount this in this bench. There is a bench here, and its point is to hold the drive in place, lock it into place so that you can work on the drive without it moving around. So everybody has a bench in front of them. This side with the bracket in it is for 2.5-inch drives, and this side right here is for the 3.5-inch drive. So, and then they're made to take out, so you can put 2.5s, you can put 2 2.5s in, or whatever else. So I've already moved the electronics before I got to this point, pulled off these screws so that they weren't talking to the electronic board itself, so that this piece would be free and clear. And then sometimes there are screws that sit in the magnet, and you have to look at it. Sometimes there'll be a position where it holds the magnet in place. Sometimes a screw back here, sometimes 2 screws on the side. If it's a IBM, there'll be 2 more screws. Well, you got to make sure those things are out. And then what will happen is I will take the magnet and I will approach the drive. So I'll be sitting on the bench like this, and I will approach it like this so that I'm not coming down and doing this. Okay? Because once you hit your head assembly, you may cause a scratch or cause something to happen. So I come at it this way. Once I get to the edge, I slide it up onto there. So I'm being very careful to take this magnet and put it up on top of their magnet and do it in a way that does not cause it to touch the head assembly and cause the head assembly to move. Okay? So this, you want to be very cautious with that. I see people take screwdrivers and try to pry these things up instead of you taking it off this way. The problem is, if you stick a screwdriver in there and you hit that coil, you can do damage to the coil. And any change that you make in an environment that's as sensitive as something like this will cause it to stop working. So do not do something that might damage or touch the coil. It may be that you don't even get a magnet that's strong enough to pull up the magnet that's sitting right here. So you may need to maybe pry up a corner or something. So I'll use, especially from like an outside edge like this, instead of someplace that's vital like this, I'll put a screwdriver here. There's usually a little nipple that goes underneath the magnet that touches the bottom of the bottom magnet, because they're just held in place most of the time by magnetism. I can pry up the corner, and then it gives me enough to pull, and so then it will come off. So, but this is what I'm doing. I'm going to come up here, I'm going to slide it up on, I'm going to get it in place, then I can put my finger on the corner of the drive and then pull up and the magnet comes off. That's the trick. That's what you're supposed to do. Okay? So now it's free and clear, and now, because I cannot get the bottom one off till I've already got the head out of the way now. So now I've got to deal with the head in some way. Now this bench has holes in the bottom, and if this board had been off first, there's a screw through the bottom, and if I remove that screw on this head assembly, then this head assembly would come off. So that's what the hole is for. If the platters are over the hole, that does you no good. So you must make sure that the hole is where your head assembly is. Okay? So in this case, and every drive is slightly different. And it will become commonplace for you to see them and figure it out right away. It won't make much difference to you. Initially, it seems hard because every time you see one, it's going to be like, well, what is this drive doing? Why is this? But eventually you get to a spot where it just seems like, well, that's a car, and I've driven a car before. It doesn't matter where the, all the gas, the pedals, all going to be in the same place, even though they may be slightly off. That's how you'll feel about it eventually. And so you'll get to a spot where you'll just open it up and you won't even think twice about it. It'll just be muscle memory, and it doesn't matter which direction it's pointing or where it's at. You'll just do the process. So that's literally all that you're doing, is you're trying to pry this up. Now, I don't normally put this back on with the magnet. So in other words, I'm not using this tool to put it back on. I'm normally doing this by hand, and you have to be careful that you don't accidentally pinch your fingers in this process. Because what I'll be doing is, there's nipples on this particular one. There's 3 nipples. Can you see them? And so basically I'm going to take these, I'm going to try to align them back up. There'll be little holes in the position that they go in. And so I'll try to line those back up so that they're going to slide back into position, and then I can put them down and make sure that they go back in. And of course I'm blind and can't see a thing. And so I'm going to make sure that they're all back in their position. And so now it's all back in place. Okay? So that would have been my take it off, put a new hat in, then put the piece back on top of it. Okay? So it's not real difficult to do from that standpoint, but I'll pass this drive around so you guys can play with it. Everybody's got a tool in front of them. Now, here's the other thing. All of these tools that I have here, I have duplicates in case something breaks, something doesn't work, or it's not working right, or tape is ripping off or whatever. I've got a box of them over there. So if anything is bent, anything doesn't feel right or do whatever, you're free to get another out of the box over there. And if something happens, laptops blow up or something like that, I keep at least one redundant laptop. If 2 of you go, we got a problem. But if 1 of you goes, we can figure it out. And so I keep redundant stuff for everything else that's in here, because something's usually going to blow up one way or another. Anyway, so I'm going to pass this drive around so that you guys can all play with it and just try to do exactly like I did to get that out. You can do it on the bench, you can do it in your hand, whatever you want to do from that standpoint. So that's all that tool is used for. If you wanted to make your own and not buy one, take a magnet out of another drive and just screw that thing onto a screwdriver, or weld it onto a screwdriver, or something that's nice and sturdy, and cover it up again with heat shrink. That's all you got to do, and then you'll have one of your own tools that you don't have to go and buy a special tool to take it around, or learn how to weld or whatever it is. But you can make your own tool pretty easily from that standpoint. And then the bench. So I buy these benches. It comes as a whole kit: the magnet, the bench, and then there's going to be these other 2 tools that look like coffee cans. And they are basically the same size as a coffee can. I've seen somebody make one out of a coffee can. So it is possible to do those things. It is possible to do the recovery, although none of you look poor from that standpoint, so you don't always have to try, or you can spend some government money from that standpoint to get these things done. You can make all of your tools yourself. You don't need any of these things. As a matter of fact, Scotch tape will work in place of the coffee can tool that we're going to talk about here in a minute. You can actually do it with Scotch tape, electrical tape, HVAC tape. There's a couple of different methods to make things work if you don't have the tools. I would say it's way easier if you're going to do a lot of redundant things and you're going to try to remember the process. It's better to have the tools. So if you can, get your hands on the tools. I assume some of you might already have the tools in your lab. If somebody else was doing it before, do you guys have?
I would assume so.
Platter tools?
I've never been in the room.
We just got access to the room.
Oh, okay. All right, somewhere in the room, there is probably this, and there is probably a set of these. Okay? And again, these are the kind of things, they start out cheap. Like this whole set is $750 to begin with. There are places you can get them that are cheaper, and there are also higher end options, like HDD surgery has a higher end option. So there are different ways of doing this process. but this is the process I prefer, and this is the way that I generally do almost everything. So inside of this tool, there is this thing that looks like a coffee can. So this metal piece is meant to move up and down, so that if you have multiple platters, as it sits over it, this piece will move up. And it will protect the top platter. And I'll show you an animation in a minute that I made, because you don't want your screws or your screwdriver stabbing the platter, because you're going to have to take screws out of the top of a spindle assembly. This piece right here works completely on pressure. So what happens is, as it goes around the platters, this piece, as you push it down, creates pressure evenly around all the platters. So if you have 3 platters in a kit, you can pull them up and take them all out at once, and it keeps them all aligned to each other. You should really try to never separate the alignment of the platters. So if they're all together as one, you should keep them as one. I will warn everybody right now, so if everybody listen, make sure you're clear on this. In between every set of platters, there is some sort of a separator. And it does not have grooves. It is not locked in any way. There's no screws holding it in place. Only the pressure from the top is holding it in. As soon as you take out those screws and you pick this up, it will stay aligned if you keep it straight. But if you go like this, it's going to go clunk, clunk. And those little rings are going to fall down, and then you're going to be jiggling and trying to get it right and pushing with your finger and trying not to get fingerprints on it and get it back in place. It is much, much easier if when you take this off of your hard drive, you pick it up and you put it down and you take your hands off of it. That's the best thing to do. Everybody's going to do it, somebody's going to do it. You're going to go, oh wow, and it's going to fall. And that's what, as long as the platters haven't come out of the holder, you're okay. We can get it back. We may have some jiggling to do and a lot of work to do, but we'll get it back. But in the meantime, that's the way you do this. So this tool, and basically I'm going to skip ahead. Like in every bag, there's tweezers, there's a toolkit, there's screwdrivers, there's torque. So those are all in the bags. And these are some of the other things that I had already talked about earlier. This is what I want to talk about. These are the coffee cans. So basically at this point in time, I'm going to do this. I'm going to show you an animation that will make it very clear what the point of this is. I made this many years ago, and it has sometimes made its way around on some people's sites. But I made this. This is our tool. So, well, technically the tool I bought from Salvation Data, this right here, but we made the animation to display how it works. All right, so this piece inside is to protect the top platter and to protect you from stabbing it and screws falling on it. And this outside edge is going to create the pressure. There's the V that goes all the way around. I'm going to show you how this works. So I already have a hard drive. I've already cleared out everything except the platters. There's nothing else in there. Just the platters are in there, so heads are removed. So I put it around, I increase the pressure, it's holding all of the platters down. Now, I don't want you just letting screws fall all over the top. I'm doing that for presentation purposes to let you know it's protected. And so if it does drop, you do drop a screw, it's not terrible, it's not going to kill it or do anything. So now I'm going to reassemble, so basically I do the exact same thing. I put it back together, all my magic screws go in. And then after you undo this, it'll hold down everything. So as long as you haven't twisted or turned, all of the spacers in between are going to stay in place. And then I made this look really easy. I'm not kidding when I say that. You know, you'll see on Friday, you'll maybe see this again. You'll be like, it's nothing like as easy as you made it look in this animation. It is physically what happens. It just isn't quite a 5-minute job. It's like an hour-and-a-half job. So in this process, that's what you're doing. Everybody understand what the whole point of the tool is now, right? To keep them all aligned, hold the platters together, remove the screws, and move on. Now, there are 2 sets of tools. That one is for 3.5, and then there is a small tool for 2.5. They're identical to the same process. Everything's the same. The only difference is that there is a small one and a large one. Okay? So you will not use the small one till Friday. The large one you will be using every day from now till then.
How much are those?
The whole kit, the way I bought it, is $700 and change. However,
That's everything?
yes, the magnet, the bench, and all of these things. However, I will tell you that AliExpress Everything you're buying, you're going to buy from China, whether you like it or not. There's no other option. Everything comes from China for any of these pieces, except for the other stuff that comes from Russia and Ukraine. And so AliExpress is your way to go. And roughly a kit like this is $250 or so on AliExpress. That would be your best bet at this point. Okay. Now I will tell you that this kit, for anything prior to 2010-ish or so, you need to try to maintain all of the platters together in one single piece. However, since then, drives have had some slight changes to them, and you can now separate the platters. And as I said, HDD Surgery makes a tool that you pick up the platters individually. So you can now separate them individually. And theirs is more expensive. I think it's like $600 or something like that.
Suction one?
It's not a suction, it clips. It like clips inside on the edges. So it's not suction per se, but it looks like that. It looks like that's what it's doing. However, there are also some tape methods that you can just use tape. Like I could literally take Scotch tape, like when there's nothing else in here, I could take Scotch tape, push it up against the edge of the platter, spin the platter, and make the Scotch tape go all the way around, and then just rub it really hard all the way around again to make sure that it's pushed up against all the platters and none of the platters are going to fall out. Then when you remove the screws, you have a cone and you pick it up and you put it down. So there's cheap ways to do this, okay? There is one problem, there is one huge problem that happens that is why HD Surgery designed their tool the way it is to pick up individual platters. And that's something we've been fighting since 2011, 2008, something in that range. They started adding in what they call acoustic vibrations brackets. So their whole point is to diminish vibration so that the heads aren't vibrating inside the platter and it creates more airflow. But our problem is that my tool won't fit around that if there's in between the platters, if there's a shape there. So there's a C shape that's sitting in between two platters. See the problem? Now there is another way to do this. There's an expensive way and there's the cheap way. The expensive way is $6,000. The cheap way is about 50 cents. So there's a difference in...
So extreme.
Yeah, right? It's an extreme difference. So it requires an explanation first of what the difference is that to make this happen. So there's only one reason you're taking the platters out. What is it?
Another drive, right?
Why would I take the platters out? The motor is seized. So the motor has to be seized for me to remove the platter. And the motor is the simplest component in the drive. It is the least likely to fail. It is the least likely to have an electronics problem. It is the least likely, because there literally is a coil that when you apply power, causes the magnet to spin around it. So it's not like a car engine or anything like that. It's a very simple process. Almost never happens that it breaks. What happens is it seizes because somebody dropped it and then the platters shifted inside or something like that. So, maybe one drive a month or whatever it is when that happens. And that's not the same as a stiction problem where the head's just stuck to the platter, because that doesn't cause the problem for it not to spin. So I just want to be very clear that the amount of work I'm going to tell you right now sounds like a pile, sounds like a large quantity that you have to do. The day will come when you do have to do one of these choices for the amount of work that goes with this, that it's not going to be as simple as the tool that I just showed you. Because you're going to run into one of these that's going to have a bracket in the middle, and they won't always be plastic. They will also be metal. And when you get to these kind of things, it becomes harder to do. But this is where the deviation comes in. A company years ago, trying to solve this problem, came up with a method where they have milled out and carved out all of these pieces that will hold all the platters in place as one assembly, and then you can use an arbor press. Anybody know what an arbor press is? An arbor press is those, basically you're just putting a lot of weight. I have a picture of an arbor press coming up. But an arbor press, basically, you're going to use your arm to push down on a lever, and there's going to be some piece that's pushing 1 ton of pressure. You buy them by the ton. So you say, I want 1 ton of pressure, I want 2 tons of pressure, I want 5 tons of pressure. You buy an arbor press, you grab this lever, you pull it, and it's kind of like, it's not hydraulic, but it's kind of like a hydraulic press. Like from that standpoint, you're going to get the efficiency of it. So they milled out a piece that pushes on the bottom of the drive. And so there is a way to do this that even with, you still have to buy your own arbor press too. Even $6,000 doesn't get you an arbor press. You have to go buy your own arbor press. So I had a big fight with them years ago, so I came up with an alternative method. I have like a $300 method that you could do the exact same thing. I published a video showing my $300 method as opposed to their $6,000 method on how you could do exactly the same thing, make your own parts. Because you can actually use a hard drive. Because a hard drive, everything in the hard drive is exactly the same size. They actually milled out their own pieces that were the same size. Well, I just took a hard drive apart and I cut them up and they all fit into the same sizes because they are physically the same size. So I found a way to do it and I published a picture, a video, a whole video, an hour video on how to do it. It takes you 8 hours of practice to do one drive. So there's a couple of methods that I can tell you that things will work. But here's the irony of the whole thing. I can go to Home Depot and I can buy HVAC tape to do ductwork, and I can just surround the drive platters with that piece, including that metal piece, and dump it all out upside down, and it'll all just go right back together inside of another drive. And that's great if you only have maybe 4 platters. Once you get past 4 platters, now accuracy becomes a bigger problem. Okay? Most drives will be less than 4 platters in this arena. So once you get past 2014 or so, now you can pull out the platters individually in the drives. So now you have alternative methods where maybe another $200 tool might be a good investment so that you can do the old drives, the new drives, and have this window of opportunity in between. Does that make sense? So basically I can mill away at all the things that happen piece by piece. I will do it with HVAC tape in the class and show you how it works. I am very skilled at it at this point. Understand I've done thousands of drives, and out of those thousands of drives, maybe, I don't know, 150 of them I've had to do by hand and get them to work with HVAC tape. And then I've taught a class 8 or 10 times a year and did it in class every time. So it requires practice. And if you try it, you will get it, but you will have to practice over and over again. You can use the same drive to practice on, just not the client drive. Does that make sense? So you'll see what happens. But I just want to make this point. All right, so let's go through what the problem is, and then we'll see everything that happens. So, well, over the years, there's been other people who came up with some other solutions. There are some other solutions. They're not as elegant. They're not great. There's $800. I can solve this problem cheaper and faster than buying this. This is all from India and China. This is a piece from China. This is some pieces from India. They cut out spacers. They cut holes. The problem is not every single drive that has this C-shaped thing are in the same place. So you can't use the same tool for all the drives. They're all different. So you have different cutouts for every single drive and every single model. Same thing that happens with your head assemblies. So I don't need any of that, but that's what happened here. The India ones, they made different ones with different cutouts, and you can pop them together. This is $800 for their set. Some people really like them. I've had students that bought them and loved them and send me notes about how much they love them, and that's fine. If that's what you want to do, if it works well for you, it's one option. That's why I'm showing it. And so this is HDRC, and they're out of India, and they make a pretty decent plastic tool set. And they have like all different kinds and all different sizes that go with all the different drives, and so you'll get a full set. They kind of look a little bit like this inside for all of them, and they'll all be cut differently. And they use a pressure point on the outside with foam. There's a foam rubber piece right here, and you put the thumb screw in, and it holds them together. I own all of these, so I've done them all. But it isn't something that I use every day, even though I have these tools. There's a lot of things that muscle memory and motion and being able to do the skill has paid off for me. So I've done them until I've gotten them. And once you get them and you have that skill, again, it's perishable. You have to keep trying it and doing it over and over again. But once you get it, you're a winner, and you don't have this problem from then on. So here's what happens. This is called a fluid dynamic bearing. Now this part on the outside is where your platters are sitting. There's a cap stand that sits on top, and that's what this piece is, where the platters sit. And they're just sitting on top of these spacings right here. And then when you screw that piece in through the top that has the screws on it, it's just putting pressure over the ring and holding them down. That's all that's happening. So this piece right here, the white area right here on that inside ring is a magnet. So it's a circular magnet, and so this is a circle. And so basically all it's waiting for is right here in this space. You can't see it in this picture, it's not in here. There's a stator. And so again, like I described, it's basically the same thing that you've seen if you've seen an airplane with a propeller on the front, the alternator, a motorcycle stator, any of those things. And I'll have a picture right there. This is what a stator looks like. It's basically pieces of metal with it wrapped. The cord is wrapped in there. Then the pins come out, and there's a plus and a minus. And there's not a whole lot to it at all. But that's what happens when that turns on. This part right here becomes an electromagnet, causes the motor to spin. Okay? If you reverse your voltage and you do it the wrong way, your motor spins the wrong way. And that's bad, bad, bad. I'm just going to tell you, if you wire it up by hand, it's bad news to go backwards. Okay? It'll just run the head right into the platter and just rip itself apart. So I don't do them by hand that way. I use a board with its connectors and its layout because I can always test that. There's no trick to it. I'll show you shortly if I'm going to test something. This is the fluid dynamic bearings. This is what is inside the motor of the drive. It doesn't have any moving parts or anything with regards to electronics. It has one pin that goes down through the shaft. At the bottom there's a piece of copper. And in the middle of the shaft is some grooves. At the bottom there's a little reservoir. The little reservoir has ester oil in it. If this was called fluid bearings, the fluid would be there all the time. It would be in the shaft. Fluid dynamic bearings means that it's going to move up and down the shaft dynamically. So it's going to pull at the bottom. As soon as it starts to spin up, the movement of it spinning up creates pressure, causes the oil to go up the shaft, and it keeps it lubricated while it's running. But you can see where there would be a problem if the temperature is too cold or something. I mean, it takes a lot to freeze ester oil. I don't even know what temperature that would be, negative 300 or something. But if it's cold, it still takes a lot to get that to move up the shaft. So that's sometimes why they seize or somebody drops them. So once this pin seizes, it basically welds itself. You cannot move it. I promise you, there is no, I mean, you'll move heaven and earth before you move this. It will not go. You cannot turn it at all, ever. It will be welded as a piece of solid metal. So you have one job you could do is to remove this and replace it. So you could literally figure out a way to pull all the platters off together on the capstan, punch that out, and replace it. That's what my movie that's an hour long that I did at a conference and presented, I can do that. I can literally pull off the whole platter set. There's some complexity, and like I said, it will take you 8 hours to set up a whole gig to do it, and you'll have to do one per drive. But I don't need to do it most of the time at all. I'll just use tape and move it over. So this is a picture of what ball bearings looks like and fluid dynamic bearings. Before 2005, we had ball bearings. After 2005, everything switched to fluid dynamic bearings. They're very quiet, they're high temperature, they don't make any of the problems, none of the stuff that we had problems with ball bearings. Ball bearings would degenerate inside the track that they were in and cause it to seize, and then you'd have to kind of grind them till you got them to move out of their position. So that we did use a tool, and there was a tool that somebody made to grind them to get that to happen, but they don't sell anymore. But that's what this thing was. Like, so this is a tap set, and he made this piece so that you could put it in a tap set and you could grind out your ball bearings. I mean, these drives are easier to deal with anyway, so I just pick up the platters and move them to another one. It's really not that big of a deal from that standpoint. So this would only be for people who were trying not to move all your pieces. But I'll just move them to another motor and just be happy. So, okay, so it's not that big a deal. Anyway, so let me show you what this looks like. So this is the patent diagram for what it looks like. This is the ball bearings and the tracks. All they did was replace this and put a pin in the middle, and this holds it in place. And that pin is pushed through with 1 ton of pressure. So basically this entire piece is pushed with a 1 ton arbor press, or whatever they use in the robotic world that's equivalent to the arbor press in this process. So I can punch that out and punch that out, and I can replace it in place. And so that's what that video is about. You can go to YouTube and just look for Scott Moulton and go look at the video, and it will be easy to describe, but I will tell you, you will find an easier way. So that piece is what seizes. This is what it looks like inside. There's a pin that goes through the top, puts into a piece of copper, and then this cap goes on the bottom with some extra oil. This is what the inside of a real one looks, and I can't tell you how hard it was to beat the crap out of that thing to get it open, but I got it open, and you can see these grooves. You can see the extra oil. These grooves cause it to go around in a circle, and then it starts to go up the shaft. It looks like this inside the shaft. So basically it will create a nice amount of pressure evenly all the way through the entire thing. So here's all the details on extra oil and what happens to it. And then this is what happens when you're reviewing like heat and pressure and friction and all the stuff. But when one goes bad, this is when it all goes wrong and it has seized and welded itself. Okay? So every single one of these is at a different height. If you are going to use my $300 or the $6,000 method, it doesn't matter which way you've used this, when you push one of these out and you break that seal and you put a new one back in, you have to measure it and get it right back in the exact same height that it came out of. That is your nightmare, because you've got to gradually keep pushing on an arbor press, put another piece in the bottom, and slowly keep shifting it till you get it back to the same setting that you were at. So that's why I say it takes a long time to practice this method, and for a while this is the best and only way we thought you could do something. But we're not doing that. That's an arbor press. That's what it looks like. A very manual process. And then I cut pieces out so that I could do this. I actually can take 2 hard drives that are same size hard drives, cut out all the pieces on the bottom one, and use that one to catch the top one when I push the platters out. So I can shove the platters out. Now this piece right here that they $6,000 kit spent all their money making, it's another bearing. All I did was cut it out and cut off the nipple at the end. And so it's exactly the same size, so I can use it to push it out with an arbor press. Again, I'm telling you much stuff you don't need to know at this moment because there's no reason to do that. That's a real stator, and when you push it out upside down, the platter actually sits on top of the stator for the bottom one, and it hovers in place. It's kind of amazing actually when you do it that way, and then I'm shocked at thinking of the $6,000 people and how much work that they did. And I just did this with another hard drive, beat the crap out of it. You really need 3 altogether because you got to take fluid bearings out of a good drive and put them in here, and you need 1 set for a tool, so you got to steal them from another drive and destroy them. So that's what ended up happening here. So, but that's the problem that we would be trying to get around, but we're not going to do that way. I can literally take tape, and again, did my hard drive make it around? Okay. So if this one happened to be a drive that had those metal pieces in it, I can literally take a piece of HVAC tape. I use the metal HVAC tape because it's very, very sticky, and so it won't separate the drives and the platters, and it holds its shape pretty well. So what happens is I take out all the stuff and the platters are free and clear. I take a piece of HVAC tape, I look at how deep the platters are. So if there's 3 platters, I cut a strip big enough for the 3 platters. And I only want to touch the 2 on each end. I don't want extra. I don't want there to be more above or more below. I make the strip as close as I can to just the platters size themselves. Then I run that tape down the edge. And there's usually going to be a piece of metal right here where the screws go through, and I can touch that piece of metal. I just have to make sure I don't touch the bottom piece of metal. So some of them have like a little clip or a holder, so I'll cut it with my tweezers. I'll run that piece of aluminum all the way down to here. I'll push really, really hard, make sure it's stuck to all the platters. I remove the screws, I put the lid back on, I flip it over, and it all falls out into the lid upside down. Doesn't touch anything, it sits on top of the cap stand, it doesn't do anything to the platters or anything, just as long as I do that. Once I take this off, I can take a new one that I've already cleaned out, it's already done, and it's empty in my hand. I can take it and put it right back over the lid and push right back down, and it sits right back on top of all the platters. Flip it back over and we're done. Now, I'm not saying I don't have to make some alignment changes there once I got that back on, because I've moved to a new motor. So the balance is going to be different. It's gonna, even if it's just wobbling just a little bit like that, it's enough to throw the head off. The head thinks that that's 1,000,000 miles an hour. So if you're flying a helicopter over the edge of it, it's gonna think that any change in that is enough to throw it off, and you won't be reading data. And so you can make small adjustments with it. As an example, I have 3 screws on the top of this capstan. That means I have 3 places I can turn this capstan, this wheel, to. This wheel is a little bit like a balance on a tire. Some of them even have a cutout in the side, so they'll be like the balance of a tire. So I'll mark where I started with a pin. There's a permanent marker in your bag. I'll mark it. I'll back these screws out, turn this little tiny wheel on the top, 1 turn, and screw them back on. And then look at the balance and see if it's any better. If one of those positions is better than all the others. And I can usually get it to align to one of those, and then get the heads to align to it. Does that make sense to everybody? You've seen all this happen, right? So, did I do tape when you were here last time? Okay. So that's a newer process that I've come up with since then. And so you, again, if you want to be really scientific about it, because people are looking for the scientific method a lot of times, you can watch the video, you can spend 8 hours, you can go through my process, because I detail every single thing out, how I did it, what I shaved, what I cut, and how I got it to work. So you could do that if you want to, or you can be done in 10 minutes, one or the other. So, but again, I came up with another method because I fly to another country, and I need to do a data recovery, and I travel like this. I mean, I got a carry-on bag. That's what I got. And I don't usually take a lot more with me. I don't like to take a lot more with me. Especially the Atlanta airport. I don't know if you've heard these stories, but the Atlanta airport loses 300,000 bags a year. 300,000 bags disappear. And I've had my bags disappear on my way to Australia, and then not be able to do anything at all when I get to Australia. I've been over there at their little Target and trying to get, there's the TJ Maxx version or whatever it is they got over there, and I'm just buying like slippers and underwear so I can survive while waiting for a bag to show up for 3 days. So I got there and my bag was still in Atlanta. So after 2 days, because that's the problem. It's 36 hours, 30 hours to get there. So, all right, so we're going to skip everything with soldering for the moment. We're going to cover soldering on Thursday, but I will tell you this. Western Digital drives all have some sort of serial chip on them. Most drives do these days. And not every drive ever had them, like Mac Store drives and things like that. But you're always looking for the ROM. The ROM has data on the board that you need to take with you. And so this is what it looks like. It's a very small 8-pin most of the time. There's a few older ones that'll have T-SOPs, like 40-pin T-SOPs and 48-pin T-SOPs. They're a little harder to solder, but not that much harder, especially with infrared. But most of your chips are like this. They're a 2-minute job, and you're done, and it's over. And you've got all the stuff you need. You desolder this chip, put it on a new board, and you're fine. And so we will get to that as we progress. We will talk about that. We are typically not doing things like this damaged chip, which is a motor control chip, actually. So I don't even need a motor control chip to do this. I would just take this chip with me and put it on a new board. And we'll talk about boards and stuff later. With the limited amount of time I want to get to, I'm going to skip the soldering. We'll talk about that on Thursday. We'll talk about these on Thursday. So when we're talking about firmware tools, so here's the thing. Things did exist that no longer or should exist, honestly. The Atola Insight tried and started out trying to do firmware. Dimitri says he gives up. He's not doing it. PC3000 has all this reverse engineering. They've spent decades doing it. They're way farther ahead than anybody else. So he's not even going to try anymore. He just abandoned the code that's in there. It's still in there. Still in the forensics version. But it is not a firmware tool anymore. It was. He has stopped calling it that, and he is not going to try anymore. Dimitri has told me personally. I mean, we've met several times. We've spent a lot of time together. Spent 2 days going over bugs and things before, and designing part of the forensics tool, because there were some things I wanted in it that he didn't have. And then I went with him to one of the in-case things to show the product. at one of the in-case things, and it was the next year that basically became the $50,000 table. And so, because Dimitri actually called me after I'd done a presentation somewhere, and I said, all these things are not equal. I showed some tableaus and what happens when the tableaus have problems. I showed some Falcons, what happens when the Falcon has a problem imaging. And then I showed the forensic edition of the Atola doing an image. And I said, so see, you don't have the evidence. Only this machine is the only one that actually collected the evidence. All you guys got was a bunch of zeros. And so you guys can stick with in-case and do this if you want, and Tableau and do this if you want, but you're not getting the evidence. And so it's funny how collecting porn in a data recovery scenario is more important than collecting evidence in an actual criminal case. And then Dimitri calls me and he goes, I don't know what you did, but it's working. My table at in-case now is $50,000. So it's like he got blacklisted and blackballed out of the whole thing. It's like it became a big problem, but I don't know that he was too happy about it that day. But it did show, your better tool might not always win the war if you're in a scenario where somebody else is in control. Luckily, guidance is now bought by OpenText. You guys know this story, right? Anybody using guidance? Anybody using in-case? IEF went the way it did and then became Axiom, and it's one of the few times I feel like now I was wrong. Like, it's pretty rare that I predict how something's going to go and it doesn't go that way, because I didn't feel like we needed another player in that market. I wanted them to stay in the market they were in rather than just keep adding more and more cost to the expense, because that's what they did. When they went, IEF was like $79 back when it first came out. It was like nothing. And then Magnet bought them and it went up like $3,000. Yeah. So, I mean, because I've used them for 20 years now. I've used it from the original first IEF version. And to now have that expense and it be so high and a renewal rate from a commercial entity, that's a pretty hard aspect. But it does do some things nothing else can do. I know that's not particularly interesting to you from this standpoint, but basically the whole point of it was to collect all your web access and give you a report of all your web access. And it does other stuff now. Still a few problems in there, but my guess is they were too expensive to be bought by Celebrite, because that's really the tool that should have gone to Celebrite. They're actually fairly close to a stamp. Like, that first thing I ever do with a Celebrite image after I process it in Celebrite is put it in Axiom and process everything else that Celebrite didn't do. So, all right. These are all cell phone things that we're talking about at this point. But, all right, so firmware. You only have one choice, and since the price dropped, there's no point in doing anything else. You stay with PC3000, don't bother with anything else, you'll waste your time. The only other choice that you have is MRT, which is an offshoot. It's a Chinese product that basically stole all of PC3000's code. That's the best way to put it. So, because when you're talking about all those things, once you get outside of Russia and Ukraine, everything else is a copy. So, and I feel like Dolphin's basically the same thing. So those are your other two options out there. MRT's got one thing going for it. They came up with a licensing plan that allows people to scale up and scale down on a monthly basis. So if you have jobs that you're doing that you need some kind of hardcore imaging going on that's involving firmware, you can license it for like $300 a month. And so instead of spending $7,000 on a tool every time you need something, they're doing this monthly licenses. And so I know several data recovery companies, they're adding 2 or 3 at a time and then backing them back down to 1 or 2 every month. So to image drives on that process. But it's basically it's a clone of PC3000. It does not do anything PC3000 does not do. There's not a single thing that Dolphin or MRT does that PC3000 doesn't do. Okay? And they're very complex, hard problems. They're software-wise, they are the hardest thing. I can probably tell almost any of you. I can give you a piece of software you've never seen before, put you down in front of it, and in 15 minutes you've got something functional and running. Not PC3000. You may never get PC3000 that way. You may never. Every time you plug in a new hard drive, PC3000 changes its configuration. And you get different menu items, you get different options, and all your commands are different for every single drive. Every drive. And I've never seen them all, so I've never seen all of them. No matter how many times I say that, it's not possible. It's just not. And there are some problems that you'll have that they have a solution for that you'll only see once in your whole life. But that's the only thing that will fix them. So we'll get into that a little bit more as we keep going, but I'm just going to say, as far as products go, that's your PC3000. You get a stack of boards, that's pretty much it. Highly privacy protected. It must be bound to the machine you're using it in. You cannot move it. You cannot relicense it to anything. You have to only have one license sitting in one box all the time. $7,000 basically. This is what the screen looks like. And you'll see some things that are always the same in all the data recovery equipment. Like you'll see all of your status flags and all of your error flags. And it's also one of the only tools that just tries to show you if it can parse a password out of your system right away. So if it just comes up and loads it, you already know the answer to the password. And then you can get past problems that are mounting the drive or getting into the drive. Or maybe those passwords are also your golden keywords in forensics tools. So, but this is fundamentally what you're looking at for the base. It is the only tool that you can click something and not know what you clicked and it brick your drive and you never get it back again. There are things you can do just by trying menus. Like a lot of people who practice software, they just try something until they figure out what works. If you do that here, you will destroy your drive. There's no doubt in my mind whatsoever. There are certain things that people will be like, I don't even know what that command means, and they clicked it. And there's some that don't say okay. There's some that don't even say that. Like you click a button and then it just goes to town. And you don't know what that meant. You don't know, it had no description. There was nothing coming up. The manual is, it was written in 1970 or something. Like it's not current. The manual is nothing like what it is currently, and it doesn't have anything in it that will help you out at all. It has like old 2000 boards or something in it, and ROM, and how to plug the machine in, and that's pretty much it. Like the rest of the stuff does not tell you how to use it. There's no user guide. There's nothing that describes this process. DeepSpar is a little bit better than that. They have 7 pages. So that's about it. There's not a lot of things going on here. This is the old Insight, which is what he's still using. So this is the USB version of the Insight, and then there's the new Forensics version, which is the one I have up here, and then there's the Task Force, which is over there.
I got that one.
Yeah, right. Well, these still look basically the same. The process still looks basically the same. I mean, it's more advanced. It is also the only one that's 64-bit. I don't have anything hooked up to it, but this is what it looks. Oops. This is basically what the Atola looks like to begin with, and once you put in a drive and you power it on, it senses the drive, and then it starts to run through all of the reports that it can. And I will show that. We will get to that spot and I'll go through it. But it has a diagnostics phase. That's one of the best parts of the tool, is that it tries to at least tell you what you can and you can't do. If it is broke, it's like everything else. You have to do the manual repair before it will do anything. So you won't make any more advancements from that standpoint. But some of the things that the Atola can do that none of the other tools can do, like it can make an in-case image. So it's possible to make an in-case image. You can make compressed images. You can do several different processes, which you cannot do with any other tool. Now, when you're doing in-case images, it's not doing all the data recovery features that it can normally do. So you have problems with certain things overlapping that you can't do in compressed files that you can do with just clones. So typically I always clone something, then I make an image of it afterwards, so that I'm never short on the features that I have from that standpoint. And you can keep adding drives. So you can keep adding, there's multiple drives, multiple sources, multiple destinations. The Task Force is by far the one that has the majority of them. You can do 18 different drives at once. So you can do physically 18 different drives. Yep.
So I've done a little bit with this, but can you only adjust the head map, or can you actually say like, hey, I want an image with only head 1? Yes,
you can select them.
Okay.
So the Atola, unlike the DeepSpar, so they have 2 different methods of doing it. And the PC3000's method can do both of the other ones. So the PC3000 has a firmware option. You can modify it in firmware and does it permanently. So I can say turn off a head on a platter permanently, which would be great if, say, you were a terrorist and you want to fly through an airport and they want to image your hard drive. If you have a head turned off on one side of a platter, they can image all they want. They'll never see what you have on the one side of the platter. You can literally do that. Turn off one side of one platter with one head, put whatever you want on that platter first, and then turn it off. So you could manipulate it and do that. And there's a RAM function. So RAM function is temporary. It means turn off the head while I'm imaging in RAM so that I don't use this head. The DeepSpar uses both the DeepSpar and the Atola use the RAM method. They do not do it permanently. Technically what they're doing is they're turning off the zone tables for those heads. So the zone table is like a small football field of data that's contiguous data before it starts over again with another one on the same side of every platter. They do that for speed. They break them up for speed. And so what happens is the DeepSpar examines it in advance, and it takes time. The DeepSpar isn't instantaneous. The DeepSpar goes to town, pulls the zone map, and then gives it a table inside of memory, and you click, I want to turn the head on and turn the head off, and it will turn off the zone map for that table. The Atolla does it on the fly. It calculates it for every single thing it's touching. So it seems almost instantaneous in the Atolla. So the Atolla, when you're doing it, if it supports it, it doesn't support every drive, even drives that could be done in RAM with the PC3000. You sometimes have to ask them to do more work on a module or something, like certain drives, because it's a newer device. They don't support a lot of older drives that have been around for a long time, because if they haven't run into them, and there's no reason to go back and add a 2001 drive to the list. But they'll do it if you ask them. And so the big deal is if they support the head map for the process, next to, there'll be a box down here after you looked at all the heads, there'll be little check boxes next to it in the imaging box. So there'll be an imaging box and there'll be two heads, and they'll have check boxes next to them, and you can literally uncheck the head and it just won't image that head. So you can do it on the fly, you can do it in different settings and configurations. I will show that when we get that. I might have to find a drive that supports the head maps on for it to do it. If it doesn't, it just treats it all as one space, like a single head. So it'll be in there, it'll show that. But right now I just don't have a drive hooked up like I do to the DeepSpar. The DeepSpar has a module, and the module is down at the bottom. You see this build head map? So you have to know what drive you have, and I have a Toshiba connected, and so